I'm going to record this too. Okay, so let's bring up the lab for routine. Okay, so not this part. Okay, so this part right here, right? So you'll then create your own model that calculates the average normal vector and uses this to derive the average slope for the entire grid. I actually don't have this on hand, that part. So anyway, Veronica, can you restate the question there, and then I'll give you the formula. Yeah, your question, which I've received from other people as well. One of them is for us, but he's not here. Right. Okay, so yes. Thanks for refreshing my memory.
Yeah, no worries. I know the formula in the word, the reading capacity. I'm just having syntax.
Actually trying to implement it. That's right.
Yeah.
Okay. Okay, so let's let me bring that up. Oh, that's cost distance. Yeah, it's lab 5. I brought up lab 5, but I didn't bring up, I'm trying to bring up the figure from lecture 5. What's that?
I think from the beginning to the end, I was kind of counting on that video slide, and she's at the end, so she followed along.
Okay. Well, I'll make the video offline, but this is the only formula you have to implement right here, Veronica. You don't need to do aspect. I just asked for slope in the lab. Okay. I don't know if you had a problem with that one, but have you calculated the sum x, sum y, and sum z?
Yes, I'm at the mean sort of portion.
Okay, good. All right, so back in ArcGIS here. So yeah, I didn't actually even do that part in the lab, but I can go back and do that, but not right now. So. You have to keep in mind that when it runs, that it's just running Python in the background. I know you're not all Python programmers or anything. So if you're having issues with the syntax, it is a Python programming issue. I'm going to open up this PowerPoint. That's what I'm going to do. Okay. So pay no attention to anything else. I'm going to add 3 cells, 3 fields here. I'm going to call this sum x and sum y and sum z. And these would all be actually either floats or doubles. I don't know. It doesn't really matter. Either one will work fine, right? Okay. So those are the 3 values. All right. Then I hit save, and I go back to this. Oh, I want to enter one more field. So I'm going to add a new field called average slope. I'll just call it averages. And I'll also make that a float. Save. This is actually not something that you do. You'd actually create this data set. And do you have the values for one of the polygons? I mean, one of the zones, the circles? Okay, tell me them.
3,457.6.
3,457.6. Okay, sum y. 1719.6. Sum z.
1924, 6.8.
Like that? Okay, so now I need to calculate this from these numbers using this formula right here. Okay, so we could enter it all in as one formula. Well, why don't we try that at first and see what we get. So the sum x squared plus the sum y squared. Okay, so here I'm gonna right click on this and say calculate field. That's what you're gonna have to do. Actually, it's calculate. Yeah. All right. So there's the Python expression. In ArcGIS, you can choose between Python 3, Arcade, or SQL. We're going to choose Python 3. Arcade is like a brand new programming language that ArcGIS made up. And SQL is a structured query language is what it stands for. It doesn't have all the functionality that the Python has. Okay, so let's look at this. I'm going to start with the sum of x. So I think the easiest way to do this is to say sum of x times the sum of x. There is a squared function, but this is better. I put spaces in here. And then I'm going to add those together, sum y times sum y. I'm going to actually put parentheses around those guys like that, so it makes sure that it does the multiplication before the addition. See, like that? Okay, that gets done first. Then what's the next step? Well, I take the square root of that. Now, taking the square root, it's better to use the formula that's over here. So we got math.sqrt somewhere. See, it's right there. So I'm going to double click on math.sqrt and make sure that that is all inside of that formula. See that? So now that is the numerator of this operation.
So it's the tangent of the whole thing, not just the numerator?
It's the inverse tangent, and yes, I believe it is the entire thing. I think that's ambiguous, the way that it's written. You're right, but yeah, it's the inverse tangent of the whole thing. In fact, there is a function which I believe is easier to use called atan2. I should have mentioned this. Math. I'm pretty sure atan2 works. Let's just look up. I'm gonna look up Python atan2. Okay, so atan2 actually allows you to put the numerator and the denominator into the formula, and it's going to return it in radians. So you don't actually have to do the division in the formula, because what you're really calculating are rises and runs, you know. So you can, if we go back here and we do math.atan2, I think it's the easiest one. And you put in the y first and then the x. I'm going to experiment with both ways. So the denominator is the sum z. So that formula right there should produce everything that we need. So instead of doing a division, I actually just put a comma, because it's a function that's going to do the division as part of the formula. So let's see if this works. I'm going to copy this so that I can maybe put that right in the text for the lab so that everybody would have that. I'm going to run this and see if we get a number. Oh, we are probably going to get a number in radians. So that's a number in radians. So radians to degrees. So the last part of that formula would just be to multiply that by that. Okay, so I'm going to run it again. And that number makes sense to me in degrees. So, yeah, it was kind of a big formula, especially for people who haven't ever taken Python before. So I should probably just give you that formula. You're almost there, awesome. So I'm going to put that in the modules. I'm going to lab 5 and edit this. Then create your own model, calculate the average, blah, blah, blah. That's it right there. Yeah. Yeah, well, right. So if we look back at this formula for A tan 2, so this formula expects you to give it both the numerator and the denominator as separate values. This formula just expects you to have done the division already. Okay. So I only have you calculate the average normal vector and use this derived to average slope. I didn't say the average aspect. So I'm going to write field calculator formula for equals. Now this assumes that your fields are called some x, some y, some y. Some x and some y. So if you call them something slightly different, the formula would have to be adjusted. But other than that, it should work for everybody. Okay. All right. So I am going to stop the recording.